When finding percent of a number, there are two basic methods that we're going to talk about today. The first one is a bar model. And we use a bar model when the percent is a multiple of 10. So in our first example, we want to find 30% of a number. Okay, we want to find 30% of 250. So what does that mean? It means that the whole thing or total is going to be 250. And right down here, I've made what we call a bar model. And a bar model is simply a rectangle, and the total represented by the bar model is the whole thing, okay? And in this case, it's 250 because that's the total. Now, what we do is we divide this bar model, which is 100%, because it's the whole thing, into 10 equal pieces, and each piece represents 10%. So if I want 30%, it means I want 3 boxes. All right, and so I can do that, or I can get fancy, and I can shade in 30%, whatever you like. Okay, but the important thing is that the reason we use this for percents that are multiples of 10 is because it's easy to make 10 equal parts, because whenever we divide anything by 10, all we're doing is moving the decimal point one place to the left. So when we divide 250 by 10, we know that each of these boxes is going to be 25. Okay, because any fraction or percent model, all the pieces have to be the same. Okay, and in this case, since they're all 10%, they're all going to be the same. And then since we have 3 boxes, it's going to be 25 times 3, and that's going to be 75. So 30% of 250 is 75. Now, we're also going to do a ratio table because everyone thinks about things differently. And so there's always at least 2 ways to do any problem. When we do the ratio table, since there's no context here, we're just going to be doing part and total. And so the first column in our ratio table is always going to be our percent. So for 30%, it's going to be 30% or out of 100. So the total is going to be 100. And what we want is a total of 250. Now I know right away I cannot get directly from 100 to 250. So I'm going to leave some workspace here. So here in this part right here, I need to get a number that is a factor of 250. And the obvious one is 50. Well, that's not necessarily the obvious one. We can use 10, we can use 25. But if I look at 30, I also want to be able to divide that number by whatever I'm dividing. So in this case, you know what? Now that I'm looking at it, I'm going to divide by 10. And that actually is the default position. When in doubt, divide by 10, because again, we're just moving decimal points. So we're going to divide this by 10. And so down here we get 10, and here we get 3 because 30 divided by 10 is 3. Now, how do I get from 10 to 250? I have to multiply by 25. And you can see when I multiply 3 by 25, I'm going to get 250. Oops, no, I'm not. I'm going to get 75. Okay, and so here we see that the methods give the same answer. Now, when you want to make sure that you have that you know. The hardest part actually of percents is which is the part and which is the total. And whenever you have a statement like this, a percent of something is something else, whatever comes after the word of is going to be your total. Okay, so that's always going to be the case, and we're going to see that in the next problem, which is a word problem. So let's look at this word problem. And let's see. Okay, Anne has a new necklace, and 35% of the 40 beads in the necklace are red. So we have 35% of 40. And they want to know how many red beads are in the necklace. So remember, what we want to find is the percent of a number. So we have 35% of 40. Okay, and what did we say? After the word of, this has to be the total. Okay, now in this case, I'm going to use a ratio table as my preferred method because the percent is not a multiple of 10. Okay, the number of beads is a multiple of 10, but the percent I'm looking for is not. So now, since I have a word problem, I'm going to put some context here, and I'm going to label red out of the total number of beads. Okay, and so I know that 35% of them are red, so 35 out of every 100 beads would be red. So if I had 100 beads in the necklace, 35 of them would be red. Okay, but I don't. I have 40. All right, and again, I can't get from 100 to 40 in one step. Maybe I need 2 steps, maybe I need more, but I'm going to give myself some room to work. So again, the easy thing here would be to divide by 10, but when I'm looking, I could, and I could come up with 3.5 in the top, but I want to find a common factor of 35 and 100. Okay, and that common factor is 5. Okay, so I can divide this by 5, and then I'm going to divide this by 5. And when I go here, 100 divided by 5 is going to be 20. 35 divided by 5 is going to be 7. And so now, how do I get from 20 to 40? I multiply by 2. And here I'm going to multiply by 2, and I'm going to get 14. So there are 14 beads that are red. Okay, now let's take a look and let's see if we can do this by a bar method. Bar model, let's see. Okay, I know that the total is 40. And if I want to, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so what's going to happen here is each of these is 10%. So this would be 20, 30, 40. I'm going to stop here. You should always, actually, I'm going to put 100% here. You should always label all of yours, but I'm sure you don't want to watch me do that. So what I'm interested here in is 3 boxes. But then guess what? I don't want 30%, I want 35. So I need another half of a box. Okay, so this is why we prefer a ratio table, but again, it is doable. Okay, so what happens if I divide 40 by 10? Each of these boxes is 4. I'm going to leave this one out for a minute. Now, since I've divided this 10% into 2 equal parts, each of these is going to be 2. All right, so when I look at my shaded part, This is 3 times 4, which is 12, plus this 2, and that gives me a total of 14 red beads. So you see it is doable, but a ratio table is more straightforward. Again, whatever method suits you, that's the method that you do. Whatever you're comfortable with,